Hi, I'm Professor Angela Rasmussen from the Department of Electrical and Computer Engineering at the University of Utah. Today I wanted to go over an example of taking the Thevenin equivalent circuit when we have a dependent source in it. So to review the Thevenin equivalent method with dependent sources, you're going to again disconnect a circuit and you're going to call that location A wherever you disconnect it. And if it's not obvious where B is, you're going to put B as the ground. So this would be your A location is wherever you disconnect it from a circuit, and B would be your ground. You're then going to calculate the open circuit voltage between the locations A and B. From there, you're going to then find the RTH. So the method to find RTH is a little different than when you have independent sources. So for a dependent source, you're going to leave that in the circuit. You're going to leave all the dependent sources in the circuit. Independent sources, you're going to remove. So voltage equals 0, that means it's a wire. When you have current equals 0, that looks like an open. And so you're going to replace the voltage sources that are independent with the wire or an open for the current source. Remember to leave in all the dependent sources. So leave in all the dependent sources. That's very important. The next step is to apply an external source between A and B. It can be a voltage source or a current source. Whichever one that you apply, you're going to then find the opposite. If you apply a voltage, find the current. If you apply a current, find the voltage. So for a V test, you're going to solve for I test. If you put on an I test, then you're going to solve for V test. I usually like to use 1 volt or 1 amp because that's an easy number to multiply and divide. The next thing you're going to do once you find either I test or V test is you're going to plug it into the voltage or into the resistance equation V over I. So voltage test over I test. And now we can redraw the equivalent circuit. So here is an example. We have a dependent source, which you see here. It is dependent on this variable Ix. So the first step is to get A and B. In this case, that circuit to the right has been fully removed, so you don't even see it. And next we need to find this voltage VTH at this location. We can do this by applying a node voltage at this point, V1, and writing that node voltage equation. In this branch, I have a minus 2. In this branch, I have a minus Ix, but I want to use everything with V1 in it, so I only have one equation with one unknown. So I write that in terms of V1, which will be V1 over 4. And then this current, notice it goes all the way through that 8 ohm because there's no current going out here. And again, I don't want to include VTH because then I have another unknown variable and it's going to be more difficult to solve. So VTH minus 4Ix all over 8 equals 0. And now we need to write an equation for this Ix, and I notice it's just opposite what I wrote for the node voltage, so I have minus V1 over 4. And, oops, sorry, I did write, this was supposed to be V1. I said it right, but then wrote it wrong. So that's V1 minus 4Ix over 8. And now I can plug in the Ix equals minus 4. Ix equals minus V1 over 4. And then I can solve this circuit. So minus 2 plus V1 over 4. V1 minus 4 minus V1 over 4 over 8 equals 0. I'm going to combine all my V1 terms. So I have 1 over 4. I have plus 1 over 8. And then this one, the 4's cancel, and then this becomes a plus 1 over 8. And then I can take the 2 over to the other side. And I'm going to combine all of these. And that gives me, this will become a 2 over 8. So 234 over 8 equals 2. And then I can divide by this, which will be 8 over 4, which gives me a value of 4 volts for V1. So now to get VTH from this, I notice that if I measure from here to here, that value is V1. If I put a red wire from the multimeter, which would be my plus probe, and compare it to ground, I'm going to measure V1. If I do the same from here to here, I'm going to put my negative to here, I'm going to get a minus 4Ix. So, and then from here, VTH to ground, I have a plus to a minus. So I notice that VTH is going to be equal to this pathway plus this pathway. And measuring all those, I'm going to see that VTH is V1, a plus V1, minus that 4Ix. And recall that Ix is a minus V1 over 4, and we said that V1 is 4, so this becomes a minus 1. And VTH becomes then 4 minus 4 times a minus 1. And so VTH will be, the minuses become a plus, and so that becomes 8 volts. So that is my value for VTH. So now I want to find RTH. So for RTH, I'm going to copy the circuit. Just going to erase those off so it's easier to see. And I'm going to remove the independent sources. So erasing this independent source becomes an open for this one. I'm going to leave in the dependent source. And I'm going to apply an external source. Now, it doesn't matter whether you apply a voltage source or a current source. If you see an obvious advantage by putting one on over the other, then you can do that for a specific reason. For example, if I put a 1 volt here, I then know that this 1 volt is the same across all of this wire. That means that it is the same across this 8 ohm, and my current, if I call that I1 in that 8 ohm, is going to be 1 over 8. So that gives me an easy number for the current, and I can then also do the same here. I can get an equation for that, and then this is going to be my I test, which is my unknown value. So I need to solve for that I test. That is what I need to solve for. So taking the current in the 4Ix branch, I can then define Ix with that. This red current will be the plus from the 1 volt, and then I'm going to subtract off. I'll call this I2. So my I2 will equal 1 minus a minus 4Ix over 4. Again, that's because I hit the minus sign of that dependent source. And I2, I can see, is opposite Ix. So I can also rewrite this as Ix equal to a minus of this. The minuses become a plus. And I can multiply this 4 over to give me 4Ix is equal to a minus 1 minus 4Ix. I can bring the Ix's over to the other side, so that becomes a plus 4Ix plus 4Ix equals to a negative 1. And solving this, I get 4 plus 4, so that becomes a minus 1 over 8. So I can go back and do a summation of currents here. And I have a minus I test because that one's going in. I have an I1, which was 1 over 8 going out. And I have an I2 going out, which is opposite the IX, which is a negative 1/8. So I2 will be a plus 1/8. And I test then is 1 over 8 plus 1 over 8, which is 2 over 8. Or I can say it's 1/4. So now my RTH is going to be the voltage V test, which I set as 1 volt, divided by that 1 over 4. And so that gives me 4 ohms as my resistance. So redrawing this, I have that voltage VTH, and that's connected to the B side. My resistance gets connected to the A side, and that's 4 ohms. And my VTH was 4 volts. And that is my equivalent Thevenin when I have a dependent source in it. Thank you for watching.